ओके तो लास्ट क्लास में हमने क्वेश्चन नंबर 6 एंड किया था. नाउ वी आर मूविंग टुवर्ड्स क्वेश्चन नंबर 7. A1 में they are asking you to define the term electron affinity. Definitions आपको याद करनी है, ठीक है. So we can write it is the energy change. Electron affinity, if you recall, it's linked with the gain of electron. So it is the energy change when one mole of electrons are added to 1 mole of gaseous atoms to form 1 mole of gaseous. 1 minute, please. Yes, 1 mole of gaseous, one negative ions. So it is basically the one I wrote is specifically for the first electron affinity. So whenever examiner asks you to define the term electron affinity, or examiner asks you to define the term first electron affinity, you can write this definition in either case. जी सबको क्लियर है? तो definitions kindly याद कर लीजिएगा. Next you have again a definition. Define the term lattice energy. So it is the energy change when 1 mole of an ionic solid is formed from gaseous ions. So if you look over here, examiner doesn't use the term standard lattice energy. So there is no need to write afterwards that under standard conditions. If you will write only this statement, you will get 2 marks. ठीक है, ये दोनों definitions clear हैं सबको?
Yes, sir.
Okay. Now use the following data and relevant data from the data booklet to calculate a value for the enthalpy change of formation of zinc bromide. Okay. You might find it helpful to construct an energy cycle. Okay. So you have to find the enthalpy change of formation, and you are provided with first electron affinity of bromine. And if you see the formula, it's zinc bromide. And here we have a 2 bromide ions. So we have to multiply this value by 2. You have a enthalpy change of atomization of zinc. We have only zinc 1 ion, so it remains the same, or you just multiply by 1. Then you have enthalpy change of vaporization of bromine. Okay. It's for a bromine molecule, which means if I relate it with the change. So I can express it in this way. There is a 1 mole of bromine which is liquid, and by providing heat, that 1 mole of bromine is converted in liquid, is converted into 1 mole of bromine gas. And here we are provided with the enthalpy change lattice energy of ZnBr2. So if you recall the expression, enthalpy change of formation की जो expression है वो basically, अगर मैं इस कंपाउंड की रिस्पेक्ट से फॉर्म करूं तो it would be like this. Lattice energy plus बाकी आपकी जितनी भी वैल्यूज हैं, जितनी भी हम एंथैल्पी चेंजेस यूज करते हैं वो सब ऐड हो जाते हैं अगर हमें फॉर्मेशन फाइंड करनी हो तो. सो लैटिस एनर्जी प्लस enthalpy change of atomization of zinc and we need the enthalpy change of atomization of bromine. Then we need the ionization energies of zinc because zinc is too positive over here. So we need first and second ionization energy of zinc, and then we need the electron affinity for bromine, which must be times 2 because there are two bromine atoms. जी ये एक्सप्रेशन पहले बता दें, सबको क्लियर है? अगर किसी को इस एक्सप्रेशन में कोई प्रॉब्लम है तो प्लीज पूछें. ओके अच्छा, यहाँ पे थोड़ा सा ये क्वेश्चन ट्रिकी है इन टर्म्स ऑफ एटोमाइजेशन ऑफ ब्रोमीन. अगर ब्रोमीन की एटोमाइजेशन को आप रिप्रेजेंट करें तो आप कैसे रिप्रेजेंट करेंगे? You can represent the atomization in this way because if you recall atomization क्या है? When it is the energy change when 1 mole of a gaseous atom is formed from its element. तो यहाँ पे हमारे पास 2 bromine atoms form हो रहे हैं and here we have our 2 bromide ions. So enthalpy change of atomization must be times 2 होगी. ठीक है, ये बात क्लियर है सबको? अच्छा, यहाँ पे इशू क्या है कि उन्होंने आपको वेपोराइजेशन दी है, तो बेसिकली जो एटोमाइजेशन है ब्रोमीन की वो बेसिकली इस पूरे चेंज को रिप्रेजेंट कर रही होगी. क्योंकि ब्रोमीन बेसिकली किस स्टेट में होता है? लिक्विड स्टेट में होता है. तो फर्स्ट ऑन हीटिंग ब्रोमीन गैसियस एटम्स बनेंगे जो कि वेपोराइजेशन की वैल्यू है, जो कि इधर इन्होंने आपको प्रोवाइड की है +31. और जब अब ये गैसियस एटम जब ब्रेक होगा और 2 ब्रोमाइड आयंस फॉर्म करेगा तो दैट इज represented by 2 times atomization of bromine. तो इसके लिए मुझे डाटा बुकलेट की जरूरत है। ठीक है, इस वैल्यू को फाइंड करने के लिए डाटा बुकलेट की जरूरत है, और दूसरा मुझे किस वैल्यू को फाइंड करने के लिए डाटा बुकलेट की जरूरत है, इस वैल्यू को फाइंड करने के लिए डाटा बुकलेट की जरूरत है। ये पॉइंट सबको यहाँ तक क्लियर है? सो सी ओवर हेयर, यहाँ पे आपको बॉन्ड एनर्जी दी हुई है ब्रोमीन की, जो कि 193 है, which means when 1 mole of bromine gaseous moles are broken down to form 2 moles of bromine gaseous atom, और इसका एनर्जी चेंज आपको ये प्रोवाइड किया हुआ है 193। तो यहाँ से हमें ये एनर्जी चेंज मिल गया, इट इज 193। जी ये क्लियर है सबको? जिंक की बात करें तो जिंक, जैसे कि हमने ऊपर देखा कि इस जिंक पे पॉजिटिव 2 चार्ज है, तो विच मींस 2 आयोनाइजेशन एनर्जीज। तो यहाँ पे हम जिंक की आयोनाइजेशन एनर्जीज जो है हमारे पास क्या है, सेकंड एंड थर्ड कॉलम है जिंक के लिए। सो atomic number is 30, 908 is first ionization energy, and 1730 is second ionization energy. So we will put over here 908 plus 1730। तो ये हमने डाटा बुकलेट से वैल्यूज देखी। The rest of the values are over here, so you just need to put the values. So lattice energy is minus 2678, plus atomization of zinc is positive 131, plus atomization of bromine is positive 31, plus 193, plus ionization energy of zinc. There are 2 ionization energies, first and second, so 908 plus 1730, and then electron affinity of bromine is minus 325, but there are 2 bromine atoms, so I will multiply it with 2. So now you put the values in the calculator and solve it, you will get the answer. अगर किसी को कोई प्रॉब्लम है इसमें तो प्लीज पूछ लीजिए। और काइंडली सॉल्व करके आंसर बताइए क्या आ रहा है।
minus 335.
minus 335 kilojoule per mole. So you will write the answer over here, minus 335 kilojoule per mole. Okay. Now let's move to the C part. The lattice energies of zinc bromide, zinc chloride, and zinc oxide are shown. Explain why there is a difference between lattice energies of zinc bromide and zinc chloride. So if you see, uh, it's greater, right? So I can comment that the lattice energy of zinc chloride is greater than the lattice energy of zinc bromide. ये हमें यहाँ वैल्यूज देख के पता चल रहा है, ठीक है, अगर हम इन दो वैल्यूज को कंपेयर करें। सो व्हाट विल बी द रीजन? कैन एनीबॉडी रिकॉल which factors affect the lattice energy? Yes. Yes, can anybody recall?
The size.
And why the size? Because if you see the lattice energy, it is the change from the gaseous ions to an ionic solid. So there are forces of attraction that are developing between those ions, and the forces of attraction either depend upon the size or the charge. So if you look at these two, chloride and bromide, both have a same charge, right? But if you look in the periodic table, you will find that fluorine, then chlorine, then bromine, and then iodine. So bromide ion is larger in size than chloride ion, and hence weaker forces of attraction between zinc and bromide as compared to zinc and chloride. That's why the lattice energy of zinc bromide is smaller. ये point सबको clear है? So it's for 1 mark. So you don't need to write the everything. You just write one reason that bromide ion is bigger in size than chloride ion. Hence, attraction between zinc and zinc 2 positive ion and bromide ion is weaker. ठीक है, ये statement clear है सबको? Or you may write that weaker than zinc 2 positive and Cl negative, because Cl का size chloride ion का size छोटा है, smaller है, तो stronger forces of attraction है. Yes, is this clear to everyone?
Yes, sir.
Explain why there is a difference between lattice energy of zinc chloride and zinc oxide. Okay, so if you look at the position, here you have, for example, group 16 and there is group 17. So you will find oxygen over here, chlorine over here, and chlorine over here. So, and oxygen, when it becomes oxide, it have a -2 charge and it have a -1 charge. So there are two factors. One is that oxide ion is smaller than chloride ion, and oxide ion have 2- charge, which is greater than Cl negative. That is -1. उसका -1 charge होता है. So zinc oxide की greater lattice energy होने का reason, there are two reasons behind. कि एक तो उसका size भी छोटा है, it's smaller in size, plus it have a more charge, and hence the attraction between zinc 2 positive ion and O bromide ion will be greater than zinc 2 positive ion and Cl negative ion. Is this clear? So you may write that oxide ion is smaller in size than Cl negative. Further, oxide ion has 2 minus charge which is greater than 1 minus charge of chloride. Hence, stronger attraction between zinc 2 positive and O2 negative as compared to zinc 2 positive and Cl negative ion. Is this understandable? अगर किसी को कोई क्वेरी है या कोई डाउट है तो प्लीज पूछ लीजिए. Okay, next question. Question number 8, the last question of this paper. Again, you have a definition. Define the term standard cell potential. So you can write it is the potential difference between two half cells under standard conditions, and you may mention the standard conditions. That is 1 atm pressure, 298 Kelvin temperature, and all solutions are 1 mole per dm cube. तो ये आप कंडीशंस भी साथ मेंशन करेंगे. जी ये क्लियर है सबको?
Yes, sir.
An electrochemical cell is set up to measure the standard electrode potential of a cell, that is E0 cell, made of cobalt 3 positive and cobalt 2 positive half cell and a chlorine chloride half cell. Complete the table with the substance used to make the electrode in each of these half cells. Yes, can anybody identify which electrode we will use over in these two cases?
Platinum and platinum.
Very good, Ahmed. So you all must remember, if both are ions, then the electrode must be of platinum. If a non-metal half cell is made, then also in that case as well, the electrode is of platinum. So you will write for both the cases platinum. Okay. Use data from the data booklet to calculate E naught cell. Okay. तो डाटा बुकलेट से हमें E naught cell calculate करना है. So to calculate E naught cell, we will use E naught reduction minus E naught oxidation. Remember, reduction, the one which have a higher value, and the oxidation, the half cell which have a lower value. So let's see. Here you go. Okay. So if you look over here, we have cobalt 3 positive and cobalt 2 positive. So there are two equations having a cobalt in them. One have a cobalt 2 positive and cobalt, but in our case, in our half cell, we have a cobalt 3 positive and cobalt 2 positive ion, so we exclude this equation. But if you look at the other equation having a cobalt 3 positive and cobalt 2 positive ion, it means we use this equation over here. And for that equation, the value is positive 1.82. So let me write over here positive 1.82 volt. Now the second equation have a chloride and chlorine. So it's over here and its value is positive 1.36. ये clear है सबको?
Yes, sir.
So the cobalt 3 positive and cobalt 2 positive half cell have a greater value, which means it undergo reduction, and chlorine chloride half cell have a smaller value, which means it undergo oxidation. So positive 1.82 minus positive 1.36. Yes, क्या आंसर आ रहा है?
0.46.
0.46. So positive 0.46 volts. ये clear है सबको? Now they are asking you to write the equation for the overall cell reaction. Okay. So अगर मैं cobalt की equation लिखूं, तो it must be cobalt 3 positive gaining an electron and cobalt 2 positive is forming. In the same way, chlorine gaining 2 electron and forming 2 chloride ions. as we have decided earlier, this one is undergoing reduction and this one is undergoing oxidation. So the one where the oxidation is taking place, you have to first flip that equation. तो आप अगर इस इक्वेशन को फ्लिप करेंगे, सो आपके रिएक्टेंट्स प्रोडक्ट साइड पे चले जाएंगे और आपकी जो प्रोडक्ट है वो रिएक्टेंट साइड पे आ जाएगी. तो हमने इक्वेशन फ्लिप कर दी. नाउ you have to balance the electrons in both the equations. So in the second equation we have 2 electrons, in the first equation we have only 1 electron. So if I multiply the first equation by 2, my electrons in both the equations are balanced. ये clear है part सबको? Now you just add both the equations. When you are going to add both the equations, the electrons get cancelled because they are on the opposite side of the arrows, and you are left with 2 cobalt 3 positive ions and 2 chloride ions on the reactant side. Okay, ये बात याद रखिएगा कि जब भी आप नेट इक्वेशन बना रहे होते हैं, ओवरऑल इक्वेशन, in that overall equation you don't use the reversible arrow, you just use only the one direction arrow that is showing the forward reaction. And in the products we have chlorine and we have 2 moles of cobalt 2 positive ion. So that is my overall equation. और इसी इक्वेशन को मैं यहाँ पे लिख दूंगा. जी ये इक्वेशन सबको क्लियर है?
Yes, sir.
Okay. Now a fuel cell is an electrochemical cell that can be used to generate electrical energy. A methanol oxygen fuel cell can be used as alternative to hydrogen oxygen fuel cell. When the cell operates, the carbon atoms in the methanol molecule are converted into carbon dioxide. Okay, and here we have an equation. Now what they are asking, calculate the volume of carbon dioxide gas. We have to find this. In centimeter cube, formed when a current of 2.5 ampere is delivered by the cell for 30 minutes. Assume the cell is operated at room conditions. Okay. ये यहाँ पे room conditions बताने का reason क्या है? Because they are asking you the volume of a gas. So you may relate or you may recall that 1 mole of a gas occupies 24,000 centimeter cube. ये बात सबको याद है?
Yes, sir.
Okay. मुझे 1 मिनट दीजिएगा प्लीज. एक और बात जो आपको याद होनी चाहिए यहाँ पे कि if I relate the charge of 1 mole of electron, so how much charge 1 mole of electron carries?
96,500.
Good. 96,500 कूलम. अगर आप में से किसी को याद नहीं है ये चार्ज, तो आपको पेपर के एंड में periodic table और ये वाला टेबल प्रोवाइड किया जाएगा. And here you have this value that is called Faraday's constant, and Faraday's constant is basically charge of 1 mole electrons. Okay, तो आप यहाँ से ये पेपर के एंड में आपको ये टेबल दिया जाएगा, पीरियोडिक टेबल से पहले वाले पेज पे आप वहां से ये वैल्यू देख सकते हैं. Okay, so if we look into this equation, we have a 6 moles of electrons and 1 mole of carbon dioxide. So I can make the ratio between the charge and the volume of carbon dioxide. So according to the equation, I am getting 1 mole of carbon dioxide, which means 24,000 centimeter cube of carbon dioxide is forming. So I will put the value over here, 24,000 centimeter cube. Now, if it comes to charge, there are 6 moles of electrons, which means that the charge over here in this reaction is 6 times 96500 coulomb. So I will make the ratio that 6 times 96500 coulomb charge is to 24,000 centimeter cube of carbon dioxide gas. ये सबको clear है?
Yes, sir.
Okay. In this question, we are provided with 2.5 ampere current that is passed for 30 minutes. If I multiply it by 60, so I will get the time in seconds, and that is current. And current times time give me the electric charge. तो इतना 2.5 एम्पियर करंट और इतना टाइम के लिए वो करंट यूज किया गया है. So how much volume of carbon dioxide would be formed? That must be x. Now you just need to find the x. So x would be equal to 2.5 times 30 times 60 times 24,000 divided by 6 times 96500. अगर इस रेशियो में किसी को कोई कंफ्यूजन है तो प्लीज पूछ लीजिए, अदरवाइज यू कैन सॉल्व इट एंड यू विल गेट द आंसर इन सेंटीमीटर क्यूब्स.
One 186.5.
186.5.
G.
Okay. So 186.5 centimeter cube. Yes, is it clear to everyone?
Yes, sir.
Okay. So here we have ended this paper. I have shared the next paper that we have to start. So shall we start today or in the next class? Yes.
The next class, sir.
Okay, so what I have decided that we have a class on alternate days. So now our next class will be the day after tomorrow. Okay, और जरा सब रेडी होके आइएगा, हम थोड़ा सा सेशन एक्सटेंडेड रखेंगे ताकि हम जो है ज्यादा कवर कर सकें. ठीक है, तो टुमारो इज सैटरडे, तो संडे 12:15 पे हम क्लास स्टार्ट करेंगे और फिर सब रेडी रहिएगा तो हम सेशन जो है एक्सटेंड करेंगे ताकि हम जो है मैक्सिमम पेपर अटेम्प्ट कर सकें. ओके.
Right.
Okay, then take care everyone. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.